So in today's video, we are going to have a discussion on how to find the minimum value, the maximum value, and where it occurs using the method of completing the square. Let's begin our discussion with linear and quadratic functions. A linear function is a function of the form ax plus b, where a and b are all constants. A is called the slope or the gradient and b is called the intercept. Let's look at some examples of linear functions. Example of a linear function is 2x plus 1, 2x plus 6, and then 3x. For f of x, a is equal to 2 and then b is equal to 1. For g of x, a is equal to 2 and b is equal to 6. And for h of x, a is equal to 3 and then b is equal to 0. The graph of a linear function gives a straight line which depends on the value of a. So that if a is greater than 0, then you have a graph that looks like this. And if a is less than 0, then this is what you have. Now let's talk about quadratic functions. A quadratic function is a function of the form ax squared plus bx plus c, where a, b, and c are all constants and a is not equal to 0. The function has a minimum value when a is greater than 0 and a maximum value when a is less than 0. Now let's look at some examples of quadratic functions. Given a quadratic function, f of x is equal to 2x squared minus x minus 1, 3x squared or negative 3x squared minus 1, and then 5 minus 2x minus 9x squared. Each of the functions has a minimum value or a maximum value. F of x has a minimum value because a is equal to 2 and a is greater than 0, or better still, 2 is greater than 0. G of x has a maximum value because a is equal to negative 3 and negative 3 is less than 0. The same applies to h of x. A is equal to negative 9 and then negative 9 is less than 0. The minimum or the maximum value of a quadratic function is given by the formula negative into bracket b squared minus 4ac divided by 4a, and it occurs at x is equal to negative b divided by 2a. So let's solve an example. Given a function, say f of x is equal to 3x squared minus 2x plus 1. What is the minimum value and where does it occur? Now, from the equation, we know that a is equal to 3, b is equal to negative 2, and c is equal to 1. So we are going to substitute the values of a, b, and c into this equation. So it's going to be negative into bracket negative 2 all squared minus 4 into bracket a is equal to 3, so we have 3, and then c is equal to 1, so 1, divided by 4 into bracket 3. Negative 2 squared is 4, and then negative 4 times 3 is negative 12. Negative 12 times 1 is negative 12, divided by 4 times 3 is 12. So it's going to be negative into bracket 4 minus 12 is negative 8, divided by 12. 4 goes into 8 2 times, and then into 12 3 times. Now negative 1 times negative 2 over 3 is equal to 2 over 3, and this is the minimum value. Now to find where it occurs, we need to substitute b and a into this equation. So it's going to be negative into bracket, b is equal to -2. So we have -2 divided by 2 into bracket, a is 3, so we have 3. So 2 cancels 2, and then -1 times -1 is equal to 1. So we have 1/3. So it occurs at x is equal to 1/3. So the minimum value for this particular quadratic function is 2/3, and then it occurs at x is equal to 1/3. So now let's see how to solve this problem using the method of completing the square. To solve using this approach, we first of all need to make sure that the coefficient of the x squared term is equal to 1. Or better still, we need to make sure that the number multiplying x squared is equal to 1. So to do that, we need to factor out 3. So we are going to have 3 into bracket. 3x squared divided by 3 is x squared. -2x divided by 3 is -2x/3. And then 1 divided by 3 is 1/3. Next, we need to add and subtract the square of half the coefficient of x. The coefficient of x is -2/3. So half of it means that we are going to multiply by 1/2. 2 goes into itself 1, and then we have -1/3. And then the square of -1/3 is -1/3 squared. So let's fuse that into this equation. So it's going to be 3 into bracket x squared minus 2/3x plus -1/3 squared minus -1/3 squared plus 1/3. Now we are going to do away with -2/3x. So it's going to be x minus 1/3 all squared minus -1/3 squared plus 1/3 brackets close. -1/3 squared is 1/9 plus 1/3. So it's going to be 3 brackets open x minus 1 divided by 3 all squared, and -1/9 plus 1/3 is 2/9. So now let's multiply the 3 across. So we are going to have 3 into bracket x minus 1/3 all squared plus 3 goes into itself once and then into 9 3 times. So it's going to be 2/3. So we have 2/3. So from this, the minimum value is 2/3. And then to find where it occurs, we need to equate what's inside the bracket to 0. So it's going to be x minus 1/3 is equal to 0. And then we transpose -1/3 to the right hand side. So it's going to be positive 1/3. So x is equal to 1/3. So the minimum value is 2/3, and then it occurs at x is equal to 1/3. Let's solve some more examples. If h of x is equal to 2x squared minus x minus 1, what is the minimum value and where does it occur? So we know that we need to make the coefficient of the x squared term 1. So we are going to factor 2 out. So we are going to have 2 on the outside, and then 2x squared divided by 2 is x squared. Negative x divided by 2 is negative x over 2, and then negative 1 divided by 2 is negative 1 over 2. Next, we need to add and subtract the square of half the coefficient of x. Now the coefficient of x is negative 1 over 2, so half of it is times 1 over 2, which is equal to negative 1 over 4, and the square of negative 1 over 4 is negative 1 over 4 squared. So now let's fuse that into the equation. So we are going to have 2 on the outside, and then we have x squared minus x over 2 plus negative 1 over 4 squared minus negative 1 over 4 squared minus 1 over 2. So we are going to eliminate negative x over 2, and then we are going to get x minus 1 over 4 all squared minus negative 1 over 4 squared minus 1 over 2. Negative 1 over 4 squared is equal to 1 over 16 minus 1 over 2. So we are going to have x minus 1 over 4 all squared minus negative 1 over 16 minus 1 over 2 is equal to negative 9 over 16. And then we are going to multiply across with 2. So it's going to be 2 into bracket x minus 1 over 4 all squared minus 2 goes into 16 8 times, so minus 9 over 8. So the minimum value is negative 9 over 8, and then it occurs at x minus 1 over 4 is equal to 0, and then x is equal to 1 over 4. What is the maximum value of a function? Negative x squared minus 2x plus 3. And where does it occur? So we know that we need to make the coefficient of x squared 1. So we are going to factor out negative 1. So it's going to be negative 1 on the outside, and then we have x squared inside the bracket. Now negative 2x divided by negative 1 is plus 2x, and then 3 divided by negative 1 is negative 3. Now we need to add and subtract the square of half the coefficient of x. So the coefficient of x is 2. So half of 2 is times 1 over 2, which is equal to 1. And then the square of 1 is 1 squared. So we are going to fuse that into the equation. So it's going to be negative 1 on the outside, x squared plus 2x plus 1 squared minus 1 squared minus 3. So let's eliminate 2x. So it's going to be negative 1 into bracket x plus 1 all squared minus 1 squared minus 3. So we have negative 1 into bracket x plus 1 all squared minus 1 squared is 1 minus 3. Now negative 1 minus 3 is equal to negative 4. So it's going to be negative 1 into bracket x plus 1 all squared minus 4. and then let's multiply -1 across. So it's going to be negative into brackets x plus 1 all squared plus 4, because -1 times -4 is 4. So this is the maximum value, and then it occurs at x plus 1 is equal to 0, x is equal to -1. So the maximum value is 4, and then it occurs at x is equal to -1. In this video, we are going to learn how to use various methods to solve quadratic equations. We are going to consider the method of factorization, method of completing the square, and the use of the general quadratic formula. So what we are going to do basically is to take a quadratic equation and try to find its roots using the 3 different approaches mentioned earlier. So let's begin with the method of factorization. How do we find the roots of the quadratic equation 2x squared plus 7x plus 3 is equal to 0? Now the first thing to do is to multiply the coefficient of the x squared term by the constant. Now 2 times 3 is equal to 6. Factors of 6 are 1 and 6, and then 2 and 3. Now which set of values multiply to give 6 and add up to 7? 1 times 6 is 6, and then 1 plus 6 is 7. So this equation can be expanded to have 2x squared plus x plus 6x plus 3 is equal to 0. So now we can factorize. The GCF between 2x squared and x is x. So we have x on the outside, and then 2x squared divided by x is 2x, and x divided by x is 1. The GCF between 6x and 3 is 3. So we have 3 on the outside, and then 2x plus 1 inside the bracket is equal to 0. So we have x plus 3 in one bracket, and then 2x plus 1 in another bracket equal to 0. So we take x plus 3 is equal to 0, and then we can transpose positive 3 to the right hand side, and then we have -3. And then we have 2x plus 1 is equal to 0. We have 2x is equal to -1, and then we divide both sides of the equation by 2, and then we have x to be equal to -1/2. So the roots of the equation are x is equal to -3, and then x is equal to -1/2. So this is how to find the root of a quadratic equation using the method of factorization. Now let's approach this same problem using completing the square method. So we have 2x squared plus 7x plus 3 is equal to 0. Using this method, the first step is to make sure that the coefficient of the x squared term is 1, or better still, the number multiplying the x squared term is equal to 1. So to ensure that, we just need to factor 2 out. So we have 2 on the outside, and then 2x squared divided by 2 is x squared. 7x divided by 2 is 7/2x. And then 3 divided by 2 is 3/2 is equal to 0. The next step is to add and subtract the square of half the coefficient of x. Now the coefficient of x is 7/2, and then half of it means that you are going to multiply by 1/2. Now 7 times 1 is 7, and 2 times 2 is 4. So we have 7/4, and then the square of 7/4 is 7/4 squared. So we are going to fuse this into this equation. So it's going to be 2 into bracket x squared plus 7/2x plus 7/4 all squared minus 7/4 all squared plus 3/2 is equal to 0. Next, we are going to eliminate 7/2x. So it's going to be 2 into bracket, we have x plus 7 over 4 all squared minus 7 over 4 all squared plus 3 over 2. So we have 2 into bracket x plus 7 over 4 all squared minus 7 squared is 49, and then 4 squared is 16, plus 3 over 2 is equal to 0. Negative 49 over 16 plus 3 over 2 is equal to 0. So now let's multiply 2 across. So we are going to have 2 into bracket x plus 7 over 4 all squared minus 2 goes into itself once into 16 8 times. So we are going to have 25 divided by 8 is equal to 0. Now we had 2 into bracket x plus 7 over 4 all squared minus 25 divided by 8 to be equal to 0. So let's transpose negative 25 to the right hand side. So it's going to be 2 into bracket x plus 7 over 4 all squared is equal to 25 divided by 8. Now let's divide both sides of the equation by 2. So this is going to be 25 divided by 8 times 1 over 2, which is equal to 25 divided by 16. So it's going to be x plus 7 over 4 all squared is equal to 25 divided by 16. Now to find the values of x, we need to do away with the exponent. So we are going to introduce square root. And then we have plus or minus the square root of 25 over 16. Now the square cancels the square root, and then we have x plus 7 over 4 is equal to plus or minus the square root of 25 divided by 16. Now the square root of 25 divided by 16 is equal to root of 25 divided by root of 16. The square root of 25 is 5 because 5 times 5 is 25, and then the square root of 16 is 4. So finally it's going to be x plus 7 over 4 is equal to plus or minus 5 over 4. Now to find the values of x, we are going to transpose 7 over 4 to the right hand side. So it's going to be x is equal to plus or minus 5 over 4 minus 7 over 4. So we are going to have x is equal to plus 5 over 4 minus 7 over 4. Now because they have the same denominators, then we can simplify the numerator. 5 minus 7 is equal to negative 2. So we have negative 2 divided by 4. 2 goes into itself once, and then 2 goes into 4 2 times. So we have x is equal to negative 1 over 2. Now for the second value of x, we are going to have x is equal to negative 5 divided by 4 minus 7 divided by 4. Negative 5 minus 7 is negative 12. So you have negative 12 over 4. 4 goes into negative 12 negative 3 times, and then 4 goes into itself once. So you have negative 3 over 1, which is equal to negative 3. So the roots for this quadratic equation are x is equal to negative 1 over 2, and then x is equal to negative 3. The roots of the quadratic equation 2x squared plus 7x plus 3, which is equal to 0, can be found using the formula x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this is called the general quadratic formula. From this quadratic equation, a is equal to 2, b is equal to 7, and then c is equal to 3. So let's just replace the values of a, b, and c into this equation. So it's going to be x is equal to negative 7 plus or minus the square root of 7 squared minus 4 into brackets. A is 2 and then c is 3 divided by 2 into bracket 2. So we have x is equal to negative 7 plus or minus the square root of 7 squared is 49, and then 4 times 2 is 8, 8 times 3 is 24. So we have 24 divided by 4. Now x is equal to negative 7 plus or minus 9 minus 4 is 5, and then 4 minus 2 is 2. So we have the square root of 25 all divided by 4. So it's going to be x is equal to negative 7 plus or minus square root of 25 is 5 divided by 4. So we can have x is equal to negative 7 minus 5 divided by 4. Negative 7 minus 5 is negative 12 over 4. And then x is going to be negative 3. And then again we can have x is equal to negative 7 plus 5 divided by 4. Negative 7 plus 5 is equal to negative 2 divided by 4. And then we can have x is equal to negative 1 over 2. So the roots for this particular quadratic equation is x is equal to negative 3 and then x is equal to negative 1 over 2. So this is how to find the roots of a quadratic equation using the general quadratic formula. In this video, we are going to talk about system of equations. We are going to focus more on how to solve simultaneous equations involving one linear equation and a quadratic or a non-quadratic equation. There are so many ways in solving simultaneous equations. However, in this video, we are going to consider the method of substitution. So let's begin with this example. If x plus y is equal to 5 and x times y is equal to 6, how do we solve these two equations simultaneously? What are the values of x and y? To solve for x and y, we first need to make either x or y the subject from any of the two equations. Let's make x the subject from the first equation. To do so, we just need to transpose y to the right hand side. So we are going to have x is equal to 5 minus y. Let's call this equation 3. Next, let's substitute equation 3 into equation 2. So we are going to have 5 minus y into bracket times y is equal to 6. Now 5 times y is 5y. And then negative y times y is negative y squared. Now let's transpose 5 minus y squared to the right hand side. So it's going to be y squared minus 5y plus 6 is equal to 0. Now the coefficient of the y squared term is 1, and then the constant is 6. 1 times 6 is equal to 6. Now the factors of 6 are 1 and 6, and then 2 and 3. Now his set of values multiply to 6 and then add up to negative 5. Negative 2 minus 3 is equal to negative 5. So we can select 2 and 3. So the equation can be expanded to have y squared minus 2y minus 3y plus 6 is equal to 0. The GCF between y squared and negative 2y is y. So we have y on the outside, and then y squared divided by y is y, and then negative 2y divided by y is negative 2. We have negative 3 into brackets y minus 2 is equal to 0. So we are going to have y minus 3 and then y minus 2 to be equal to 0. So y is equal to 3 and then y is equal to 2. So these are the values of y. To find the values of x, we need to substitute the values of y into equation 3. When y is equal to 3, x is equal to 5 minus 3. 5 minus 3 is equal to 2. So we have x to be equal to 2. And then when y is equal to 2, x is equal to 5 minus 2. And then 5 minus 2 is equal to 3. So these are the values of x and y. When x is equal to 2, y is equal to 3. And when x is equal to 3, y is equal to 2. Let's solve another example. What are the values of x and y if x squared plus y squared is equal to 5 and y minus x is equal to 1? Straight away, let's make y the subject from equation 2 and substitute into equation 1. Now from equation 2, y is equal to 1 plus x. Let's call this equation 3 and substitute that into equation 1. So we have x squared plus 1 plus x all squared is equal to 5. 1 plus x all squared is the same as 1 plus x times 1 plus x is equal to 5. 1 times 1 is 1. 1 times x is x, and x times 1 is x. So x plus x is 2x. X times x is x squared. X squared plus x squared is 2x squared plus 2x plus 1 minus 5, which is equal to 0. So we have 2x squared plus 2x, and then 1 minus 5 is negative 4, is equal to 0. Since 2 is common to each term, let's factor out 2. So we have x squared plus x minus 2 is equal to 0. Now the coefficient of the x squared term is 1, and then the constant is negative 2. So 1 times negative 2 is equal to negative 2. And factors of negative 2 are negative 1 and 2. So we can expand this equation to have x squared minus x plus 2x minus 2 is equal to 0. Now the GCF between x squared and negative x is x. And then x squared divided by x is x. And then negative x divided by x is 1. So we have 2 into bracket x minus 1 is equal to 0. So that we have x plus 2 and then x minus 1 is equal to 0. So x is equal to negative 2 and then x is equal to 1. Now let's substitute this set of values into equation 3. Now when x is equal to negative 2, y is equal to 1 minus 2. And then 1 minus 2 is negative 1. So y is equal to negative 1. And then when x is equal to 1, y is equal to 1 plus 1. And then 1 plus 1 is 2. So when x is equal to negative 2, y is equal to negative 1. And when x is equal to 1, y is equal to 2. So in this video, we are going to learn how to calculate the discriminant of a quadratic equation and how to determine or describe the nature of its roots. The general quadratic formula is given by the expression x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, what's inside the square root is called the discriminant, and it is given by b is equal to b squared minus 4ac, and it is used to determine or describe the nature of the roots of a particular quadratic equation. Now, whenever the discriminant is greater than 0, the equation will have two real and different roots, or better still, two distinct roots. And if the discriminant is equal to 0, the equation will have two real and equal roots. And whenever d is less than 0, the equation will have two imaginary or complex roots. So given some quadratic equations, we should be able to calculate the discriminant and describe the nature of its roots. So let's try this together. Given a quadratic equation, 2x squared minus x minus 1. What is the discriminant of this equation, and what is the nature of its roots? We all know that any quadratic equation is of the form ax squared plus bx plus c. So doing some form of comparison, we know that a is equal to 2, b is equal to -1, and c is also equal to -1. Now let's find the discriminant. The discriminant is given by b squared minus 4ac. Now b is -1, a is 2, and c is -1. -1 all squared is 1, and then 2 times -1 is -2. So we are going to have 1 minus 4 times -2 is -8, and then 1 minus -8 is equal to 9. So the discriminant is equal to 9. Now since the discriminant, which is equal to 9, is greater than 0, it means that the equation has two real and different roots, or it has two distinct roots. So let's confirm using the general quadratic formula. Now the general quadratic formula is given by x is equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. So from the equation, a was equal to 2, b was equal to -1, and then c -1. So let's plug the values of a, b, and c into the general quadratic formula. So x is equal to negative, b is -1, so we have -1 plus or minus the square root of the discriminant, and then the discriminant was 9, so we have 9 here, divided by 2a. A is 2, so we are going to have x is equal to 1 plus or minus the square root of 9 is 3, so we have 3 divided by 4. So the first solution is x is equal to 1 plus 3 divided by 4. 1 plus 3 is 4, and 4 divided by 4 is equal to 1. So x is equal to 1. And then the second solution is x is equal to 1 minus 3 divided by 4. 1 minus 3 is -2 divided by 4. 2 goes into itself once, and then into 4 2 times. So x is equal to -1/2. So the roots of this particular quadratic equation is x is equal to 1, and then x is equal to -1/2. So the quadratic equation has two real and different roots, or two distinct roots. Let's try another example. Let's say we have the quadratic equation 4x squared minus 12x plus 9. What is the discriminant for this equation, and what is the nature of its roots? Now a is equal to 4, b is equal to -12, and c is equal to 9. And we know that the discriminant is given by b squared minus 4ac. So d is equal to negative 12 squared minus 4, and then a is 4 and c is 9. Negative 12 squared is 144. 4 times 9 is 36. 4 times 36 is 144. So the discriminant is equal to 0. Since the discriminant is equal to 0, the equation will have two real and equal roots, or sometimes we can say that it has only one real root. Now let's confirm the answer using the general quadratic formula. So once again, the general quadratic formula is given by negative b plus or minus the square root of b squared minus 4ac divided by 2a. A was equal to 4, b was negative 12, and then c was 9. So let's plug the values of a, b, and c into this formula. X is equal to negative into brackets negative 12 plus or minus the square root of 0 divided by 2a. A is 4. So x is equal to 12 plus or minus 0 divided by 2 times 4 is 8. Notice that the plus or minus affect the 0. So we can have x to be equal to 12 divided by 8, which is equal to 3 over 2. So this is the only real root of the quadratic equation. Now let's use the method of factorization to make things very simple for us. So the equation was 4x squared minus 12x plus 9. Let's say is equal to 0. The coefficient of the x squared term is 4, and then the constant is 9. So we want to multiply 4 times 9. Now 4 times 9 is 36, and factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Now which set of values multiply to 36 and add up to negative 12? Negative 6 minus 6 is equal to negative 12. So we select 6 and 6. So this equation can be expanded to have 4x squared minus 6x minus 6x plus 9 is equal to 0. Now the GCF between 4x squared and negative 6x is 2x. So we have 2x on the outside, and then 4x squared divided by 2x is 2x, and then 6x divided by 2x is 3. The GCF between 6x and 9 is 3. So we have 3 on the outside, and then 2x minus 3 inside the bracket is equal to 0. So we have 2x minus 3, and then 2x minus 3 is equal to 0. So the first one, we are going to have 2x is equal to 3. We divide both sides of the equation by 2, and then x is equal to 3 over 2. So for the second one, we also have 2x is equal to 3, and then we divide both sides of the equation by 2, and then we also have x is equal to 3 over 2. So actually, the equation has two real roots, but they are equal. So when you have the discriminant of a quadratic equation to be equal to 0, it is correct to say that the equation will have two real and equal roots, or the equation will have only one real root. Let's take another example. Given the quadratic equation 3x squared minus 2x plus 4, what is the nature of its roots? So straight away, let's find the discriminant. d is equal to b squared minus 4ac. b is equal to negative 2, a is equal to 3, and c is equal to 4. So we have negative 2 squared minus 4 into brackets 3 and then 4. Negative 2 squared is 4, and then 4 times 3 is 12, and 12 times 4 is 48. So we have negative 48, and then 4 minus 48 is negative 44. Now since d is less than 0, then it means that the equation will have two complex roots or two imaginary roots. Now let's confirm that. Using the general quadratic equation, we know that x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now b is negative 2, so we have negative into brackets negative 2 plus or minus and then the square root of negative 44 divided by 2a, and a is 3. Negative 1 times negative 2 is 2, so plus or minus the square root of negative 44, but we can separate that to have square root of negative 1 times square root of 44 divided by 2 times 3 is 6. So we can have x is equal to 2 plus or minus. Now the square root of negative 1 is equal to I. So we have I times, and then the square root of 44 is square root of 4 times square root of 11 divided by 6. X is equal to 2 plus or minus I times the square root of 4 is 2 times the square root of 11 divided by 6. So x is equal to 2 plus or minus 2 root 11i divided by 6. Now 2 goes into itself once and then into 6 3 times. So we can have x to be equal to 1 plus or minus square root of 11i divided by 3. So the first solution is x is equal to 1 plus the square root of 11i divided by 3, and then the second solution is 1 minus the square root of 11i divided by 3. So these are the two imaginary roots or the two complex roots of this particular quadratic equation. So in summary, the discriminant is used to determine the nature of the roots of a quadratic equation. If the discriminant is greater than 0, then the equation has two real and different roots, or better still, two distinct roots. And if d is equal to 0, the equation has two real and equal roots. Or better still, only one real root. And if the discriminant is less than 0, the equation will have two imaginary or two complex roots. Hello everyone. In the previous lecture, we learned how to calculate the discriminant of a quadratic equation and how to determine the nature of its roots. In this lecture, we are going to solve some likely examinable questions regarding this very topic. So let's begin with the first question. Find the values of the constant k for which the equation x squared minus into bracket k plus 1 x plus 5k minus 19 equals to 0 has equal roots. From the previous lecture, we learned that a quadratic equation has equal roots if the discriminant is equal to 0. We know that the discriminant is given by d is equal to b squared minus 4ac. From the equation, a is equal to 1, b is equal to negative into brackets k plus 1, and c is equal to 5k minus 19. Now let's substitute the values of a, b, and c into this equation. Now d is equal to b squared, and then b is negative into bracket k plus 1 squared minus 4 into bracket a is 1 and c is 5k minus 19. Now this is equal to 0. Now let's multiply negative 1 across. So it's going to be negative k minus 1 squared minus 4 into bracket 5k minus 19 is equal to 0. Negative k, negative 1 all squared is the same as negative k minus 1 and then negative k minus 1, and then we have minus 4 times 5k is 20k, and then negative 4 times negative 19 is 76. Negative k times negative k is k squared. Negative k times negative 1 is k. Negative 1 times negative k is k, and then negative 1 times negative 1 is 1, and then we have minus 20k plus 76 is equal to 0. So for the next step, we are going to have k squared. Now k plus k is 2k, and 2k minus 20k is negative 18k, and then 1 plus 76 is 77. So we have this equal to 0. Now the coefficient of the k squared term is 1 and the constant is 77. So we need to find the factors of 77 that multiply to 77 and add up to negative 18. Factors of 77 are 1 and 77, and then 7 and 11. So we are going to select this set of values. So we have k squared minus 7k minus 11k plus 77 is equal to 0. Now let's factorize. So we have k on the outside, and then k minus 7 inside the bracket, and then minus 11 into bracket k minus 7 is equal to 0. So we have k minus 11 and then k minus 7 is equal to 0. So for the first solution, k minus 11 is equal to 0, k is equal to 11. And then for the second one, k minus 7 is equal to 0 and k is equal to 7. So these are the set of values of k for which the equation has equal roots. Let's solve the next question. So for the second question, we are to find the relationship between p and q if the roots of the equation px squared plus qx plus 1 is equal to 0 are equal. So according to the question, we are to find the relationship between p and q if they are equal roots of the equation px squared plus qx plus 1 is equal to 0. Now we know that for equal roots, the discriminant is equal to 0. So d is equal to b squared minus 4 AC is equal to 0. From the equation, A is equal to P, B is equal to Q, and C is equal to 1. So let's fuse these values of A, B, and C into this equation. Now B is Q, so we have Q squared minus 4, A is P, and C is 1, and that's equal to 0. So we have Q squared minus 4P is equal to 0. So we transpose negative 4P to the right hand side, and we have Q squared is equal to 4P, and then Q is equal to the square root of 4P. So this is the relationship between Q and P. That's very simple. Now let's try this question together. If the roots of x squared minus 7x plus k is equal to 0, and m minus 1 are the roots, find the values of the constant k. So we all know that the roots of a quadratic equation is given by the general quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. From the equation, a is equal to 1, b is equal to negative 7, and c is equal to k. Now let's plug the values of a, b, and c into this equation. So x is equal to negative b. Now b is negative 7. So we have negative 7 plus or minus the square root of negative 7 squared minus 4a, and a is 1, and then c is k, divided by 2 into brackets 1. Negative 1 times negative 7 is 7, and then we have plus or minus negative 7 squared is 49 minus 4 times 1 is 4, and 4 times k is 4k, divided by 2. At this point, we realize that the quadratic equation has two roots. Now the first one is, say x1 is equal to 7 plus the square root of 49 minus 4k divided by 2. And then the second one, x2 is equal to 7 minus the square root of 49 minus 4k divided by 2. We realize that the roots of the equation are m and m minus 1. So let's say x1 is equal to m and x2 is equal to m minus 1. So we have m is equal to 7 plus the square root of 49 minus 4k divided by 2, and m minus 1 is equal to 7 minus the square root of 49 minus 4k divided by 2. So we had m is equal to 7 plus square root of 49 minus 4k divided by 2, and m minus 1 is equal to 7 minus the square root of 49 minus 4k divided by 2. So let's cross multiply. 2 times m is 2m, and it's equal to 7 plus the square root of 49 minus 4k. Let's transpose 7 to the left hand side, so that we have 2m minus 7 is equal to the square root of 49 minus 4k. Let's call this equation 1. Now for the second root, let's also cross multiply. So we are going to have 2 into bracket m minus 1 is equal to 7 minus the square root of 49 minus 4k. Now to do away with the negative sign attached to the square root, let's transpose negative the square root of 49 minus 4k to the left hand side, and then 2 into bracket m minus 1 to the right hand side. So it's going to be 49 minus 4k is equal to 7 minus 2 into bracket m minus 1. And let's call this our second equation. Now because we have the square root of 49 minus 4k in equation 1, and then 49 minus 4k, that is the square root of 49 minus 4k in equation 2, then we can equate the two equations. So we are going to have 2m minus 7 from equation 1 is equal to 7 minus 2 into bracket m minus 1 from equation 2. Now negative 2 times m is negative 2m, and negative 2 times 1 is plus 2. So we have 2m, and then we transpose negative 2 to the left hand side, and then 7 plus 2, and then negative 7 to the right hand side. So we have 4m is equal to 7 plus 7 is 14, and 14 plus 2 is 16. Four goes into itself once and into 16 4 times. So we have m to be equal to 4. So one of the roots of the equation is equal to 4. Now the second one was m minus 1, and then m is equal to 4. So we have 4 minus 1, and then it's equal to 3. So m minus 1 is equal to 3, and that's the second root for the equation. Now to find the value of k, according to equation 2, the square root of 49 minus 4k is equal to 7 minus 2 into bracket m minus 1. Now m is equal to 4. So we have 7 minus 2 into bracket 4 minus 1. Now 4 minus 1 is 3. So we have 7 minus 2 times 3 is 6, and 7 minus 6 is 1. So we have the square root of 49 minus 4k is equal to 1. Now to do away with the square root, let's square both sides of the equation. So we are going to have 49 minus 4k is equal to 1, and then we transpose 49 to the right hand side, and then we have negative 4k is equal to 1 minus 49, which is equal to negative 48. We divide both sides of the equation by 4, and then we have k to be equal to 12. So the value of k is equal to 12. So now the quadratic equation looks like x squared minus 7x plus 12. And to confirm that the roots of the equation are 4 and 3, factors of 12 that multiply to 12 and add up to negative 7 are negative 3 and negative 4. So the equation looks like x minus 3 and then x minus 4 is equal to 0. Now x minus 3 is equal to 0 means that x is equal to 3, and then x minus 4 is equal to 0 is x is equal to 4. So these are the roots of the quadratic equation, and the constant k is equal to 12. In this video, we are going to learn how to form a quadratic equation when its roots are given. Given the roots of any quadratic equation, the equation can be written as x squared minus sum of roots x plus product of roots is equal to 0. The sum of roots means that you want to add the roots, and then the product means that you want to multiply the roots. So if the roots of a quadratic equation are 2 and negative 10, how do we generate the quadratic equation? Now let's find the sum of roots. The sum of roots is equal to 2 plus negative 10, and that's equal to 2 minus 10, which is equal to negative 8. The product of roots is equal to 2 times negative 10, and that's equal to negative 20. So using this formula, we can find the quadratic equation. So we have x squared minus the sum of roots, that is negative 8x, plus the product of roots, that is negative 20, is equal to 0. So we have x squared plus 8x minus 20 is equal to 0. So the quadratic equation, whose roots are 2 and negative 10, is equal to x squared plus 8x minus 20 is equal to 0. Let's try another example. If the roots of any quadratic equation are 1 and negative 4, how do we generate the quadratic equation? Now the sum of roots is equal to 1 plus negative 4, which is 1 minus 4, and then it's equal to negative 3. Now let's find the product of roots. The product of roots is equal to 1 times negative 4, and 1 times negative 4 is negative 4. Now using the formula x squared minus sum of roots x plus product of roots is equal to 0. We have x squared minus the sum of roots is negative 3 x plus the product is negative 4, and that's equal to 0. So we have x squared plus 3x minus 4 is equal to 0. So the quadratic equation, whose roots are 1 and negative 4, is equal to x squared plus 3x minus 4 is equal to 0. In the previous lecture, we learned how to form a quadratic equation when the roots of the equation were given. However, in this video, we are going to practice how to find the sum and product of roots of a quadratic equation using the coefficients a, b, and c. Now, given a quadratic equation, ax squared plus bx plus c is equal to 0 with roots alpha and beta. Then the sum of roots is alpha plus beta, and the product of roots is equal to alpha times beta. So having obtained this, then we can generate a quadratic equation using the formula x squared minus, into brackets, the sum of roots x plus the product of roots is equal to 0. So that's going to be x squared minus, we have sum of root to be alpha plus beta, and then we have the product to be alpha times beta. It's equal to 0. So let's call this equation 1. From equation 1, it is obvious that the coefficient of the x squared term is 1. Now let's consider the general quadratic equation, that is ax squared plus bx plus c is equal to 0. Now realize that the coefficient of the x squared term is a. Now, in order to make the coefficient of the x squared term to be 1, we need to divide through by a. So as we divide through by a, we have x squared, because a will cancel a, plus we have bx over a plus c over a is equal to 0. Let's call this equation 2. So now we can compare the two equations. Now considering the x term, we have from equation 1 negative into bracket alpha plus beta is equal to b over a. So finally we can have alpha plus beta is equal to negative b over a. Now for the constant, alpha beta from equation 1 is equal to c over a from equation 2. So given the quadratic equation ax squared plus bx plus c is equal to 0, the sum of roots, which is alpha plus beta, is equal to negative b over a, and the product of roots, which is alpha beta, is equal to c over a. Now let's solve an example. If the roots of a quadratic equation 5x squared plus 2x minus 3 is equal to 0 has roots alpha and beta. Now let's find the values alpha plus beta and then alpha beta. So those represent the sum of roots and the product of roots. Now formally, we would want to use the method of factorization. So having 5x squared plus 2x minus 3 is equal to 0. Now the coefficient of the x squared term is 5, and that of the constant is negative 3. So we can say that 5 times negative 3 is equal to negative 15. And then the factors of negative 15 are negative 1 and 15, and then negative 3 and then 5. Now because we want to get plus 2, then we can say that 5 minus 3 is equal to 2. So we can use negative 3 and then 5. So we are going to have 5x squared plus 5x minus 3x minus 3 is equal to 0. So that's going to be, we are going to factor 5x out, and then we have x plus 1 inside, then we have negative 3 outside, and then x plus 1 inside is equal to 0. So that's going to be 5x minus 3, and then x plus 1 is equal to 0. Now we have 5x minus 3 is equal to 0, and then we transpose negative 3 to the right hand side, and then we have x is equal to 3 over 5. Now for the second root, that is x plus 1 is equal to 0, x is equal to negative 1. So we have x is equal to 3 over 5 and x is equal to negative 1. So let's say this is alpha and this is beta. Now if you want to find the sum of roots, that is alpha plus beta, then it's equal to 3 over 5 minus 1. Now 3 over 5 minus 1 is equal to negative 2 over 5. And then alpha beta, which is the product of roots, is equal to 3 over 5 times negative 1. And that's equal to negative 3 over 5. Now, using the coefficients a, b, and c, let's try to see if you are going to get the same answers. Now, from the equation, a is equal to 5, b is equal to 2, and c is equal to negative 3. Now, we know that alpha plus beta, which is the sum of roots, is equal to negative b over a. Now, b is 2, so we have negative 2 divided by a, which is 5. So alpha plus beta is equal to negative 2 over 5, which is the same as this. And then alpha beta, which is the product of roots, is equal to c over a. And c is equal to negative 3. So we have negative 3 divided by a, which is 5. So that's equal to negative 3 over 5, which is the same as what we have here. So, given a quadratic equation with coefficients a, b, and c, we can find the sum of roots and the product of roots using a very simple method like what we have studied today. In the previous lecture, we learned how to find the sum and product of roots of a quadratic equation using the coefficients a, b, and c. We also learned that given a quadratic equation, the sum of roots alpha plus beta is equal to negative b over a, and the product of roots alpha beta is equal to c over a. In this video, we are going to talk about symmetric functions of roots of a quadratic equation. Now, given the values of alpha plus beta and alpha beta of an equation, we can find the values of other symmetric functions of alpha and beta. A function of alpha and beta is said to be symmetric if it remains the same even when alpha and beta are interchanged. So now we are going to look at how some functions of alpha and beta can be expressed in terms of alpha plus beta and alpha beta. So now let's begin with alpha squared plus beta squared. Now alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Now if you have alpha squared, you have alpha minus beta all squared, then it's equal to alpha plus beta all squared minus 4 alpha beta. Now if you have alpha minus beta, then it's simply the square root of this expression. That's alpha plus beta all squared minus 4 alpha beta. Alpha cube plus beta cube is equal to alpha plus beta all cube minus 3 alpha beta alpha plus beta. And then if you have alpha cube minus beta cube, now note the difference. That is alpha minus beta all cube plus 3 alpha beta and then alpha minus beta. So let's note the difference between alpha cube plus beta cube and then alpha cube minus beta cube. Now if you have 1 over alpha plus 1 over beta. Then you want to find the LCM of alpha and beta, or the LCM between alpha and beta. So the LCM is alpha beta. You want to multiply alpha and then beta. Now alpha beta divided by alpha is beta, and then beta times 1 is beta. And then you do the same for beta, and then you have alpha, and that's the same as alpha plus beta divided by alpha beta. Now if you have 1 over alpha squared plus 1 over beta squared, then the LCM between alpha squared and beta squared is alpha squared beta squared. Now alpha squared beta squared divided by alpha squared is beta squared, and then alpha squared beta squared divided by beta squared is alpha squared. Now this is the same as alpha squared plus beta squared divided by alpha beta all squared, because they have the same exponents. Now alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So we can have that here, alpha plus beta all squared minus 2 alpha beta divided by alpha beta all squared. And then if you have alpha exponent 4 plus beta exponent 4, then that's equal to alpha squared plus beta squared all squared minus 2 alpha squared beta squared.